So we'll start from the very first question. So this question says that this armor blocks all attacks with power strength represented as an integer of d or less, but does not block attacks with power greater than d. Does this armor block an attack with power a? So you have to tell that your attack is less than your strength or not. If it is, then you'll have to answer it yes, otherwise you'll have to answer it as no. Like here you can see the example. If attack is your 4 and your attack is your, you know, your attack is 4 and your strength is 5, so armor can hold this, so the answer would be yes. If it is equals, then also answer would be yes. But if it is greater than, your attack is greater than the your hold your strength, then it would be no, because it cannot hold. So the code for this problem will be this. So you can see this here, like, it's just one line implementation and you'll be able to answer it. It's okay, guys. Is there any doubt? Okay, then we'll move on to the next problem, which is this. Second problem states that n woodcutters are there, and the woodcutters are represented as 1, 2, 3 to till n, and each have one axe. All of them dropped their axes into a pond, and n axes 1 to n were found in the pond. Each woodcutter I claims that I owned XAI, and on the other hand, the goddess of this hand pond knows that woodcutter who owned XI is woodcutter BI. So you'll have two arrays. You'll have two arrays. One as AI and another is BI. But in AI, your I claims that the I states that it is people who owned the XAI. But when the goddess in the goddess array, which is represented as BI, in the indices represents that it is woodcutter, and the value represents that no, the indices I is represented as X, and wood the value represented as your woodcutter. So uh, we'll check it out here. Like, so in this question, wait a minute. In this question, the first array, which was A, the I represents that it is people, and the value, which is AI, this represents your X. But in the B array, which is the goddess array, the I represents the X, and the BIth value will represents your people. Okay, so you just have to check it out whether all of the people are saying it correctly or not. All of the people are saying correct or not, because the people are claiming that that this X is mine, and but whether they are claiming truly or not, you just have to find it out. If any one of them are telling the wrong, if any one of them telling claiming false, then you will have to answer false. Otherwise, if all of them are telling the truth, then only you'll have to answer it yes. So what we can do, here we can see that an example, and let's take an this example and dry run. So this was 3 1 2 and 2 3 1. So this your AI, and this your bi, and 1 2 3 is your index. So here, this what I told you, that this the index in the AIth array, the index represents the people. So the first people claim that that your that your third x is his, the first the third x is belongs to the first people, the very first people. But when you go to the third index, here it also written as 1. So the goddess also tells that, that it belongs to the first people. So for the first index, you find out that the answer would be yes. And when you go to the second index, you will see that the x belongs to the first people, that it claims that the second people claims that the index, the second people claims that the x1 is belongs to the second people. But when you'll check it out, you'll again find out that, the goddess array also says that it belongs to the first people. So you will again tells that it is true. Again you will come here, and then again you'll check it out that for the third people, it claims that that second x would belongs to his. And when you will come here and you will again check it out, then you'll find out it's claiming correctly. So yes, all are saying correct, so the answer would be yes. So we'll again check it out. The next dry run, will next test case is, which is 1 2 3 4, and 1 3 2 4. This is your AI, and this is your BI, and the indices would be 1 2 3 4. This is your indices. So the first people claims that the first x would be his, and when you'll check it out in the goddess array, it also claims that yes, it is belongs to the first people. So yes, answer would be yes for this indices. When you go to the second people, and the second people claims that the second x would be his, but when you check it out here, it claims that the second x the third x would be his. So yes, so this is your false. This the second people claims falsely. It is wrong. So answer would be no. Answer would be no, because the second people claims false. And now you, because you get one false, so you can just print no, and you just have to return it from you just have to return from there. And you don't need to further check. You don't need to further check, because if all are true, then you'll have to print the yes, otherwise you'll have to print no. So you get one no and one false claim. That's why you just return it from here. So this is the code for the second problem. And no, this is the first one. This is for the second one. And this is the code. Here you have taken the inputs, and here you just have checked that, you will again go for whatever would be the bith value. You'll go to the you'll go to that index, and you'll check it out whether it is I or not. If it is not I, then it would, if it is not I, then then you will print no, because their claim was not correct. Their claim was not correct. So you'll print no, and you just return, because you don't need to further check. And if all claims are true, then you'll print yes. So this is the code for the second problem. And if there is any doubt, you can ask. Is this question clear to you guys? Okay.
Yes, please.
Okay. So from now on, Rinika will continue.
Good evening, everyone. Is my screen visible?
Yes, Didi.
Okay. So we are going to discuss the third and the fourth question. So let's move on. Uh, have you solved the questions? Like, have you tried solving those questions? Any one of you? Okay, let's see. So we have the third question, that is variety. Here we are given n gems and the color represented as an integer of the ith gem is Ci and its value is Vi. We have to choose k gems of this m gems. Here the chosen gems must have at least m distinct colors. Find the maximum possible total value of the chosen gems. Such a choice is always possible in the given input. So what are we given? We are given n gems and each of this gem has a color C and a value V. Now from this n gems, we need to choose exactly k gems, and in those k gems, exactly m gems must have distinct colors. Others, it doesn't matter. After that, colors may be repeated, but at least m distinct colors must be present there. And then we need to find the total maximum possible value. So this is a greedy problem. So we just need to greedily choose those gems such that we can maximize our value. But at the same time, we need to keep in mind that we need to choose m distinct colors. So what we'll basically do is, see, the input format will take n, k, and m input, and then we'll take Ci and Vi. Ci is the color of the ith gem, and Vi is the value of the ith gem. Now see how we are doing it. So basically we'll take the value Vi and Ci and then sort it according to Vi. Okay, because we need to get the maximum value, right? So we'll sort the whole array, like we'll take this in a pair, like we will declare a pair of array where each pair will consist of the color and the value. Now we'll sort this array according to Vi, and since we are sorting this in ascending order, therefore the maximum values will stay in the end. So we'll start iterating from the back side, and then we'll choose the colors in such a way such that once we choose a color, we don't choose the same color repeatedly, right? So let's see the dry ones. So what we need to do is, we'll choose exactly k gems such that the chosen gems contains at least m distinct colors. So first we need to ensure that at least m distinct colors are present, but at the same time we must greedily choose the maximum values to maximize our total sum. Now see the dry run. We have n equals 5, k equals 3, m equals 2. So we are given 5 gems. Among them we need to pick 3 gems, and which among those 3 gems at least 2 distinct colors must be present. So we have the color and value as 130, 140, 150, like this way. So what we'll do is, we'll store the gems as value and color, not as color and value, because we are sorting it according to our value. So we'll take the input as value and color. So we have the pairs like this: 31, 41. 30 is the value, 1 is the color, 40 is the value, 1 is the color. Now after sorting by values, what we get is 10, 2, 23, 31. So we have sorted the array of pairs according to the value. So the maximum value stays at last and the minimum value stays at first. Now we'll iterate the array from in a reverse way. So first we need to keep in mind, because since we are iterating it in the reverse way, so obviously we are going to pick the maximum values first. Now what we need to keep in mind is the second thing, that is we need to pick m distinct colors. So while traversing from the end, first we get to see is gem 51, gem which is the value 50 and color 1. So we'll keep a set data structure to keep in mind that we have taken that color or not taken that color previously, because we first we need to ensure that we must take m distinct colors. We don't repeat colors. We need to first fulfill that criteria. So we'll keep a set data structure which is currently empty. Now we'll look in the set. Do I have any gem of color 1? So since the set is empty, so I don't have any gem of color 1. So we are picking this gem. Now what our sum becomes, it becomes 50. Now in our set we'll insert the value 1. That means the color 1 is already used. Now we have to pick m distinct colors, and here m is 2. So already one distinct color we have already picked. Now we will also keep a used array to remember that this gem we have picked. So we'll keep a used array. In that array we'll mark this particular gem as used, like we have taken this gem. Now iterating, we'll get the next value, that is 41. So here the color is again 1. We'll search in our set that does the color 1 or we have already taken. Yes, we have already taken. So for now I need to ensure that I have at least 2 distinct colors. So I'm not going to take 40 right now. So I'll skip this value. Now I have 30 and 1. Now color 1 already exists in our set again. So we are again skipping this value. Now we have gem 23. Now we'll search in our set. Do I have taken the color 3? So I'll see, no, I have not taken the color 3. So we'll add the value 20 in our answer. So our total sum becomes 50 plus 20, that is 70. Now in our set, what colors do we have? 1 and 3. And in our used array, we'll mark that we have taken this gem 20, 3. Now we have taken 2 distinct colors. Our set size is already 2, and that means we have fulfilled the criteria that we need to take at least m distinct colors. Now we'll stop here. Now what we need to do, we'll again start in the reverse direction. Now one of the condition is already fulfilled, that is we need to take m distinct colors. Now the only other criteria we need to fulfill is we need to now maximize the sum. So again start from the reverse side, because we have skipped a lot of values because the colors were being repeated. So we skip those values. Now we will try to take those values so that we can maximize our sum. Now we are again going to iterate from the reverse side. So we've already selected 2 gems. So how many gems more do we need? We had to pick k gems. In this question, k was 3 and m was 2. So we already picked 2 gems and we had to pick 3 gems. So only 1 more gem I need to pick. Now I'll start from the reverse direction again. Now first is 51. We have already used this value in our previous iteration, so we can't use this value in our this iteration. So we already marked this value in our used array, right? So that means we have already used it. So we have already chosen it, so we are skipping it. Now we are coming to the next, that is gem 40, 1. Previously we skipped this because 1 was already taken, but at this point I have already fulfilled the criteria of m distinct colors. So now this is unused, this is not used, and we need to maximize the value. So I'm going to add this value because this is the maximum value still not used. So I'm going to add this to our sum, and our total sum becomes 110. So all k gems are selected because we already selected 3 gems. So our question stops here. Now the maximum possible value that we could select is 110. So what are the chosen gems? First we chose 51. Then we chose 23, then we stopped, and then again we started iterating from the backward direction, and then we chose 41. So the total value becomes 110. So let's see how the algorithm works. So we are sorting all the gems by value, then we are traversing from the largest value. If its color has not been used, select it, and if its color has been used, skip it. Now we are continuing this till m distinct colors are obtained. Now when the m distinct colors criteria is already fulfilled, we are traversing again from the largest value. We are going to select the highest valued unused gems which we have not used previously. Now we'll continue until we take all k gems and then output the total value. So now since we are sorting, so the time complexity is n log n, and for the traversals we are iterating through the array. In the worst case, we are going to iterate the whole array, so it's big of n. So overall it's n log n. I hope you understood the question. If anybody has any doubt, please ask, and if not, give a thumbs up. I hope anyone has any doubt.
I just wanted to know the logic that we are using to make sure that once we have minimum elements which are distinct, after that, when we are choosing the elements again to maximize, how are we making sure that we are not repeating the values again and not missing out any potential best values?
Okay, so basically we are using greedy approach. I hope you know about greedy approach, right? Like we are taking values such that we have already sorted, right? Already sorted the array. So all the maximum values are present in the all the maximum value will take when we iterate from the reverse direction. Now, once we ensure that all m distinct values are taken, now while taking those m distinct value, we are keeping an array that is used array. So used array, when you are taking any value in that particular index, we are marking it as visited. Have you solved graph problems, right? So when you are using any node, so we mark it as visited, right? So once you are using any color and using it in our sum, we are marking that particular index as visited. Now when you are iterating again after ensuring the m distinct color condition is satisfied, when you're iterating again, at that time we are particularly checking that is this value already used. If not used, then we are taking that value. Now how am I ensuring that that value is going to ensure that my sum is maximum? Because I am iterating from the reverse direction, right? So all the maximum values are already in the back because I have already sorted it in ascending order. So it's already ensuring that I am taking the maximum value, but at the same time it's ensuring that I'm not taking the value that I've already taken previously, because I'm checking my used array. If that particular index is used, that means I have already taken that particular value. I'm not going to take it again, but at the same time I'm taking the value which I've not already used, but I'm taking it from the reverse direction. So I'm making sure that I'm taking the maximum values only. I hope you can understand, right?
Yes, Didi, understood. Thank you so much.
Okay. Anybody else? If anyone has any doubt, I saw a chat.
Didi, I had one doubt that how are we storing that used array, like elements in that used array? Suppose there is one pair that 20 comma 1, then there might be a possibility that 20 comma 1 appears 2 times in the given array. So it would just neglect it 2 times. So one answer could be have 20 when like
Can
distinct
you please
colors
repeat your question?
Yes, Didi. Like I want to know that how are we checking that uh, used array, in that used array, how are we storing and checking that?
Okay,
I,
I got it. Like if I have two values exactly same, then how I am going to mark that, right?
yes, Didi.
Okay, so let me show you my code once. See, what we are doing is first of all we are taking a vector of pair of array, and then we are taking the color and the value, and then we're sorting it according to the value. Okay, now two important things that we are taking is, one is the set data structure and another is a vector bool used, which is same as the size of our array. Now each of the index of this used array represent each of the index of our this array, pair array. So even if we repeat any value, like if suppose 21 and 21 repeats, but then their index will be different, right? So in our used array, we are separating each node by their index. we are remembering that we have used this particular index. Now if I have already used one particular 20,1 value previously, so I have marked that particular index. Now two similar values can't have the same index, right? So if I've already marked that particular index, that means that 20,1 I'm not using again. But any other 20,1 which I have not used, I'll use it in my next iteration, because that is not marked in my used array, right? Because for used array, I am taking each and every index of my actual array. So value doesn't matter because we are tracking according to the index. So I hope I'm clear.
Okay, Didi.
Okay, so let me explain the code completely. So first we are taking the sum is 0 and we are iterating from in the reverse way. And this is the cost is the array I dot first and color is array I dot second. Now, if the color is already present in the set, then we are skipping that value. But if the color is not present in the set, then we are taking that value, we are adding that value to our sum. Then we are inserting this new color because further we need to keep a track. And then we are marking this index used I as 1. That means this particular gem is already used. Now I'm not going to use it again when I'm going to iterate again from the reverse direction. Now, if the set size is already greater than equals to m, that means my m condition is already fulfilled. So I'm breaking off. Now I need to pick k. Now I have already picked m. So what remaining I need to pay, that is need to pick, that is k minus m. Now I am again iterating from the reverse, that is index n minus 1. Now while index is greater than 0 and while k is greater than 0, because we need to pick k elements. Now if that particular index is not previously used, if we have not taken that particular index, then only we are adding that cost to our sum, and then we are doing k minus minus, and in every case we are doing index minus minus, and then we are printing the sum. I hope it's clear right now. Anybody else, if anyone has any doubt? Okay, fine. I'm moving on to the next question. Okay, so count subgrid sum equals k. So this question is a little bit tricky. So just try to listen very carefully. So there is an HXW grid and each cell contains an integer either 0 or 1. The information of the integer written in each cell is given as H strings S1, S2, S3, so on till SH of length W. If the jth character of SI is 0, then 0 is written in that cell of the ith row from the top and jth column from the left of the grid. And if the jth character of SI is 1, then 1 is written in that cell. Now we need to find the number of rectangular regions where sum of the written integers equals k. More formally, find the number of quadruples of integers r1, c1, r2, c2 satisfying all of the following conditions. So let me explain you the question first. So basically, we have a grid. This is a grid of height 3, 1, 2, 3, and width 4. Now, how are we given this grid? How is the input given? For each of the row, we are given a string. That is, string 1 is 1010, string 2 is 1101, string 3 is 0110. Now, each of the values of the string. Now, for the first row, the first element of the string, that is represent the first row, first column of the cell in this way. Okay. So first row, second element of the string represent the first row and second column of the grid. So let's not confuse how the input is given. Let us consider that this is a kind of matrix. We have taken the inputs in such a way such that this is a particular string, this is another string, this is another string, but overall each of these elements represents a cell. So we can basically consider this as a matrix, and each of this cell has either the value 1 or the value 0. Now what we need to do is, we are given a k and we need to find how many rectangles are there whose sum is k. Now here k is 3. So we can see this is one of the rectangle. Sorry. So I hope you can see this 1, 0 and here 1, 1. This consists of a rectangle of sum 3. Again here 1, 0 and 0, 1. This is also a rectangle. No, this is a, see 1, 0, 0, 1 and 1, 0. This consists of a rectangle of sum 3. Again this 1, 1 and 0, 1, this consists of a rectangle of sum 3. Now we need to find all possible rectangles where sum is equals 3. Now, what is the brute force approach you can think of is, we'll try all possible rectangles and then we can somehow calculate the sum and then we'll check if the sum is equals to k and then we'll count. But then this will take almost h square into w square time complexity. But according to the given constraint, that is h and w are between 1 and 500 inclusive, it will exceed the time limit. So I'm not going to the brute force approach right now. So from that kind of big of n to the power 4 kind of approach, we can think of like we can reduce it to big of n cube, like somewhat h square into w or somewhat w square into h. So we'll try this. Now how will we do it is, we'll use a concept of prefix sum. Now, let me make you understand one important thing first before going on to the question. Suppose we have a particular column in the grid that is 1, 1, 0, 1, 1. Let's not think about the question. Just think this of like a normal array question. 1, 1, 0, 1, 1. This is your array, and this is the prefix sum below. This is the prefix sum. I hope you can get the prefix sum, right? Now, what think of, suppose you are given k is 2. That is, you need to find rectangles of sum 2. Now, for this, now you are storing, suppose you are storing a map where you are storing the value I have number of rectangles of sum 2 is 2. I hope I'm clear. Suppose you have a map and number of rectangles of sum 2 is 2. Now, suppose you're taking this particular array. Now for this, the prefix sum is 4. But you need to find the number of arrays with sum 2. So in your map, you find that of prefix sum 2, your value is 2. Now, can you find up to this index, like from here, see, this particular index has sum 1. Up to this rectangle has sum 2. This rectangle also has sum 2. This rectangle has sum 3. And this rectangle has sum 4. Now, from this position, if someone asks you how many rectangles are there of sum 2, so you can say either this rectangle is of sum 2 or this rectangle is of sum 2. And can you find the complementary part of the array? That is, when you are taking these two ones, here is another array of 1, 1 and 0, which is the value that is 4 minus 2. So when you are doing 4, this is the prefix sum is 4, and what k value you are given, that is 2. When you are doing 4 minus 2, you are getting value 2. That is 2 arrays here. See, 1 array and 2 array. So this is what you need to remember, that how many, whatever previous array you already stored, whatever prefix sum you already stored, that is the value that you will require to know the current index, current number of subarrays of the sum 2. I know this is very confusing. Let's again see the question and then I'll come back to this point. So basically what we are doing is, we will try a solution of time complexity somewhat around big of n cube. So what we'll do is, we'll take a top boundary here and a bottom boundary. that will iterate throughout, that will take somewhat h square complexity. And then for the column part, we'll use this prefix sum approach. Now let's see how we are doing. Let's see the dry run. So first we'll initialize we'll take a column array and we'll initialize it all 0. Now first initially top is 0 and bottom is also 0. So let me show you my code. Okay, so first we are iterating from int top equals to 0, top is less than the height, top plus plus, and we are also taking for int bottom equals to top, bottom is less than height, bottom plus plus. So for every top and bottom, we are creating the upper and the lower boundary of the rectangle. So for the rectangle, we are first fixing the upper boundary and the lower boundary using the top and bottom thing. Now the left and the right boundary, that we are going to calculate using the prefix sum. Now let's initialize the column array using 0. Now first initially top is 0, bottom is 0. Now for row 0, so when top is 0 and bottom is 0, we are getting this particular row. Now for this particular row, how many rectangles are possible? This is one rectangle, this is another rectangle, this is another rectangle, and this is another rectangle. So we'll calculate the column for this particular row, and then we'll calculate the prefix sum, and then we'll see how many rectangles are there of value k. So top is 0, bottom is 0, that means this row. Now for this row, what is the value? 1 0 1 0. So we're filling the column with 1 0 1 0. See, this is already 1 0 1 0. Now we have k equals 3. So we'll calculate the prefix sum. Now how are we doing it? First we'll take a map data structure, and then in the map data structure we'll push that for value 0 we have one possibility. So we are doing it because we will need this value in the future. Now prefix is 0. Now for column 0, prefix is 1. See here, value is 1. So prefix is 1. Now what do we value that we need is prefix minus k. Now please go through the dry run. If you don't understand, then please ask me, but please first of all let me go through the dry run. So what we need is prefix minus k, that is value minus 2. So we'll search in the map. Do map of minus 2 exist? It doesn't exist. So we'll skip that part and we'll do map of prefix plus plus, that is map of 1 plus plus, because we'll need this in future. Now we'll go for column 1. What is column 1? 0. What is the prefix sum up to this? 1 plus 0 is 1. Now the prefix sum is 1. Now we'll search the value. See, we'll search this value, prefix minus k. Prefix is 1 and k is 3. So prefix minus k is again minus 2. Do we find minus 2 in the map? Not found. So we'll again do map of 1 plus plus. Now I'll go to column 2. So what is the column 2? See, up to column 2, the prefix sum is 1 plus 1, that is 2. Now we need k equals 3. So we'll find prefix minus k, that is 2 minus 3, that is minus 1. We need minus 1 from the map. Is it present in the map? No. So not found. So we'll add the prefix to map 2 plus plus. Now again we'll go to column 3. Now up to this prefix sum is 2. What do we need? 2 minus 3 because k is 3, prefix minus k. Every iteration we are doing the same thing. We are calculating the prefix sum up to adding one element. Like for first iteration we are taking 1, second iteration we are taking 1 plus 0, in the third iteration we are taking 1 plus 0 plus 1, in the fourth iteration we are taking 1 plus 0 plus 1 plus 0, and every time we are trying to find prefix minus k from the map. If that is not present in the map, we are doing map prefix plus plus. So here prefix is 2, prefix minus 2 is minus 1, which is not found in the map. So map of 2 plus plus. Now for this whole column, no rectangle is found that has sum k. Now we are going to increase the bottom. Now bottom becomes 1. So now what we are fixing the top here, top is still 0, bottom comes here. So for this particular top and bottom, we are going to examine for each and every rectangle. Now how for each and every rectangle? First we'll be taking this rectangle 1 and 1, then we'll be taking this rectangle 1 0 1 1, then we'll be taking this rectangle 1 0 1 and 1 1 0. Now we'll be taking this rectangle 1 1 1 0 1 0 and this whole rectangle. Okay, I hope you are able to somewhat get the approach. So when you're doing bottom is 1, now we have the column, new column as, we are going to add all these values. Okay, so see, for when bottom is 1, we have this as our initial matrix. Now we're going to add this value 1 plus 1, here it is 2. Now 0 plus 1, it's 1. 1 plus 0, it's 1. 0 plus 1, it's 1. Now for the column, for each column, we have this sum values. Now we are going to calculate prefix sum again on this. Now prefix sum, first of all, it's 0. Now for column 0, prefix sum is 2. What do we need? Need is prefix minus k, that is 2 minus 3, that is minus 1. Do we have minus 1 in our map? No, so not found. So we'll just increment map of 2 plus plus. Now for column 1, what do we have? 2 plus 1, that is 3. For column 1, we have prefix sum is 2 plus 1, that is 3. Now what do we need from the map? We need prefix minus k, that is 3 minus 3, which is 0. Does map 0 exist? Yes, map 0 exists. In this case, we are going to add 1 to our answer. Now come here in this question and see, do you see that in this particular rectangle, we have sum equals 3. So what we are basically doing is, we are fixing the top and then we are iterating the bottom, and we are fixing the top and the bottom, and for each top and bottom we are calculating the sum of the columns, and for each sum of column we are calculating the prefix sum, and we are checking if that particular prefix sum minus k is already present in the map or not. If it is already present in the map, we are adding that to our answer. If it's not present in the map, we are simply adding our prefix to our map. Now again for column 2, our prefix sum is, see, for column 2 our prefix sum is 4. What k value we have? That is 3. So 4 minus 3 is we need 1. So is it present in the map? So not found. So we are doing map 4 plus plus. Now for column 3, what is the prefix sum? 2 plus 1 plus 1 plus 1, that is 5. 5 minus k is 2. We need 2. Is it already present in the map? So map of 2 is 1. Yes, it's already present. So we are doing answer plus equals 1. So what it takes is this particular rectangle 1 0 0 1. So in this way we are doing. Now let me make you understand again. So how is this map thing going? I hope you have understood the top and bottom thing already, but how is this map thing working? So this is working in this way. Suppose this is the prefix sum. Now for this particular rectangle, suppose k is 2, when k is 2, now up to this we need to find for prefix minus k in the map. Now up to this the prefix is 4, prefix minus k is 2. So prefix minus a map of 2 is already 2, because we have already seen 2 subarrays of sum 2. One is this one, another is this one. Now for this particular subarray, we have this subarray, which is our new, which are going to add to our answer. And for this particular subarray, we have this subarray, which we are going to add to our answer. So basically we are adding in our answer the value of map of prefix minus k. I hope you are getting this point somewhat. What we are doing is, for this whole array, we have prefix sum is 4. But we need to find any sub array with sum k, that is 2. So we need to subtract 4 minus 2. We need to find all the arrays that already has taken 2 and we need to remove them. So how many arrays have already taken sum of 2? One is this one and the another is this one. So when you are removing this array, what is left? 0, 1, 1. So this is one of our answer. And when you're removing this array, what is left? This one. So this is one of our answer. I hope you're getting it now. Now let's understand once again. So basically we are taking top and we are taking bottom. We are taking for every top, first top will be 0, top will be 1, top will be 2. And for every top, we will take bottom as from top to edge. So first bottom will be for top 0, bottom will be 0, bottom will be 1, bottom will be 2. Now, what we are doing with this top and bottom is we are fixing the upper and the lower boundary of the rectangle. Now for the column part, we are using prefix sum. How are we using prefix sum? When the top and bottom is this one, that means the top is here, the bottom is here, and we have only this particular rectangle. Now in this rectangle, the prefix sum is for this particular element is 1. So what we need in our answer, that is how many rectangles have sum k, that is sum 3. What is the sum here? Sum is 1. So of course this is not in our, this will not come in our answer. So we'll do is prefix minus k, that is 1 minus 3, that is minus 2. So this minus 2 is not present in our map, so we are not taking that. Instead what we are doing is map of prefix sum, that is map of 1 plus plus. Why? Because in the future we might need, suppose in some case we are getting prefix sum as 4 and k is 3, so we are subtracting 4 minus 3, we need map of 1. So have you already seen map of 1? Yes, we have already seen. So we are marking this here because in future if I need that map of 1, which I need to remove, so that I can find at that point how many arrays. So for that I'm storing it now. Now again I'm going to this part. Again prefix sum is 1. Is what we need is prefix minus k, that is 1 minus 3 minus 2. It's again not present in the map, but we are going to increment the map 1 value by 1 because again this particular array also takes 1. Now suppose you had to find the rectangles whose sum is 1. First you will take this one. Second, when you will come to this prefix sum, listen carefully, when you come to this prefix sum, this is the sum is 2, but you need array of sum 1, right? So what are you going to subtract? You are going to subtract 1 from it, right? Because prefix sum is 2, prefix minus k is 1, so 2 minus 1 is 1. So you need to remove all the arrays that have sum 1, and for every of those array you are going to get a new array. So first of all, this is one array which gives sum 1, and when you remove this is the array that also gives you a sum 1. So this is one of the answer. Now this is one array which gives you a sum 1, and if you remove this part, this is also one of the array which gives you sum 1. So for every already present array that you have pre-calculated that gives you sum 1, you are getting another new array. I hope you can understand. Let me explain from this. So why do we need map of prefix minus k? See, suppose we have prefix 5 and we have k equals 3. Then what we need? Prefix minus k, that is 2. For every previous prefix sum equals to 2 forms a valid subarray ending here. So we need all subarray that we'll need all rectangles that has sum k, but that is ending at that point where you have calculated the prefix to be 5. That is ending at that point, right? But so we need to remove all the previous array that had sum 3, okay? Because okay. So I hope, okay, so prefix is 5 and we have k is 3. So we need to remove all the rectangles from our calculation. That takes sum is 2. Then only we're going to get rectangles of sum 3, right? So we will find from our map has how many rectangles were previously there that has sum 2. So map will tell us that we had 4 rectangles which took sum 2. Now for each of these 4 rectangles, we'll get another 4 rectangles that will give us sum 3. How are we getting this? See, this is similar here. So for here we are calculating, suppose at this point we have prefix sum 4, and here what we need to find is how many rectangles ending at this position has sum 1. Suppose k is 1. For now we are taking this particular prefix sum. Now for this index, how many rectangles do are there with sum k equals 1 which are ending at this index? Now we need k equals 1, but prefix sum is already 2. So we'll remove for how much sum we need to remove? That is 2 minus 1. That means those many rectangles which are taking sum of 1, we need to remove them because we need another half sum of 1, right? So we can remove this one. So if we remove this one, we are getting this array. So already 1 is there. If we remove this one, we are getting this array. So already there were 2 rectangles of sum 1, and when we are removing those 2 rectangles, we are getting 2 complementary rectangles which are giving us our answer. So since map was already storing this value, that is 2 rectangles, this one and this one, for sum 1, we'll just take that value and add it to our answer. I hope you can understand it. So we need to, for every previous prefix sum equals 2 forms valid survey ending here, and there are 4 different surveys ending at current position whose sum is exactly k. Therefore answer plus equals map of prefix minus k. Prefix minus k, how many values already we stored in our map? All of those previous values is going to give me answer for this particular required answer. Okay, so see again, for every top row, we are going to take a column vector and we are going to extend bottom from top to h minus 1. Now, once we fix the top and bottom, we'll take the current row in the column and we'll find the prefix sum of that, and then we'll store the values in our map so that we can use them in our future to find our answer. So its complexity is somewhat big of h square w, and I know it's very tricky. I know most of you couldn't understand. Any doubt, please ask. I am ready to re-explain. Anyone has any doubt?
The last question was a little difficult for me to understand fully. Is there any related concept or similar questions that you would recommend solving so I can understand that better? I've solved
Previous
more
question, like the
like the
C
last.
or this one. Okay, this one. Okay. So you can try. You have basically, I would suggest you first go through the thing and try to understand how it is happening. Okay, so I hope you have understand that part, top and bottom part, right? Like if I could like visualize you, then it would have been better. But I hope you understood the top and bottom part. We are fixing the top and the bottom, right? The rectangle. For the rectangle, you're fixing the top and the bottom. And for the column only, we are confused, right?
Yes, yes.
Okay, so in explaining once again. So in complete brute force, what we do is we go from top to bottom and then we go from left to right and we find all possible rectangles. So for the top to bottom, we are doing the same here. But for the left to right, we are saving our time and we are calculating the prefix sum. So if I show you how we are doing it, let me write here. So first, see, I'm explaining you. first we have this column 0, 1, 1, 0. Now we'll calculate the, now here, can you understand, top is here, bottom is here. So this is the particular rectangle, top and bottom is already fixed. Now how many rectangles are possible here? This is one rectangle possible, this is another rectangle possible, this is another rectangle possible, and this is another rectangle possible. 4 rectangles are possible here. Now we have to find all rectangles of sum 3. Now we'll calculate the prefix sum. Now for this one, prefix sum is 0. Here prefix sum is 1. Here prefix sum is 2. Here prefix sum is sum is 2, C2. Now what will do? Prefix minus k again. Prefix minus k is, that is 2 minus 3 equals minus 1. So is minus 1 all present in the map? No, minus 1 is not present in the map. What is our prefix sum? 2. So we can store in the map that I haven't found my answer yet, but I already have a rectangle whose sum is 2. So for future use, I might need this, that I have a rectangle which has sum 2. And how many rectangles have sum 2 till now? 1. Now we'll come to this rectangle. Now for this rectangle, prefix sum is again 2. Now we'll do 2 minus 3, again minus 1. Does map has minus 1? No. So map doesn't have minus 1. So what we'll do is, okay, so for future use, I must store that map has another, so map has another rectangle of sum 2. So for sum 2, we already had one rectangle. Now we found another rectangle. This was one rectangle already that we already had calculated previously. Now we found another rectangle of sum 2. So for sum 2, we already have 2 rectangles. Now we are going to the next column. What is the next column? 1, 1, 0, 1. Now again we'll calculate the column sum for this rectangle. Now how to calculate the column sum? Here 0 plus 1, that is 1, 1 plus 1, that is 2, 1 plus 0, that is 1, and 0 plus 1, that is 1. So this is the column sum. Now we'll calculate the prefix sum for this. Now for calculating prefix sum, here 1, and here 3, here 4, here 5. Now I am going to search again in this. Now till now can you get this thing, that now we are checking for this particular rectangle. Now we have calculated the column sum here 1 0 1 1 1 0 0 1, so that we can directly calculate for this particular rectangle, this up to this particular rectangle, up to this particular rectangle, and up to this particular rectangle. I hope you're getting it. We already calculated this, this and this, but now we need to calculate this rectangle, this rectangle, this rectangle and this rectangle. Now for that we are calculating the column values. Now we have calculated the prefix sum. Now here prefix sum is 1. Now we need to find 1 minus 3. Now 1 minus 3 is minus 2. Does map has that value? No, map doesn't has that value. So what we'll be storing, that is, I have once again found an rectangle of sum 1. So we already had one rectangle of sum 1. Now we have two rectangles of sum 1. Can you see? This was one of the rectangle of sum 1, and this is one of the rectangle. This 0 and 1 vertically. This is one of the rectangle that we have sum 1. So we might need this in the future. That's why you are storing this. Now again, we are going to this particular value here up to this. Can you see? This is the prefix sum. Actually, this is the prefix sum is representing this particular thing. Now here the prefix sum is this will be 3 and okay. So this is 3. So up to this part we have sum is 3. Now what is prefix? 3. Now what is k? 3. Now what is this? 0. So does map has the value 0? Do we had any rectangle with value 0? Yes, we already stored that in our map. So okay, we found this. So what we actually found? We actually found a rectangle of K3. This is the rectangle that we found for K3. So we are going to add answer plus equals MPP 0. This is what we are, because we already stored, right? Now we are going for this up to this. So up to this, the what is the prefix sum? That is 4 for this rectangle. See, this is 4. Now we need to find 4 minus 3. 4 minus 3. Now 4 minus 3 is 1. Now we need to find all rectangles ending at this particular position, ending at here. So we need to find any rectangle ending here. So up to this whole sum is 4, but we need sum 3. So we need to remove all rectangles of sum 1, right? So what are the rectangles that had sum 1? This is one of the rectangle that had sum 1. And what is the another rectangle that we had sum 1? That is this one. So if we remove this one, we'll get a rectangle. If we remove this particular one, we'll get a rectangle this 1, 1 and 0, 1. And so while removing one rectangle, we are getting another rectangle, right? So if we remove all the rectangles of sum 1, we'll get all the remaining rectangles of sum 3. So how many rectangles of sum 1 was already pre-calculated? That is 2. So how many new rectangles we are going to get? That is 2. So here we already had prefix sum 4, but we need all rectangles of sum 3. So we need to remove all rectangles of sum 1. Now when we are removing any rectangle of sum 1, we are getting any rectangle of sum 3. So how many rectangle of sum 1 was already stored? That is 2. So how many rectangles of sum 3 we are getting? If we remove that 2 rectangles, we are going to get 2 new rectangles of sum 3. So we answer. Now again we will do answer plus equals map of 1. So this is how we are doing. I hope you're getting it right. Now again, when we are coming at this position, we have prefix sum as 5. Now prefix sum is 5. Now what we need to find? We need to find rectangles of sum 3. So we need to remove all rectangles of sum 2. How many rectangles already had sum 2 we pre-calculated? That is, we already had 2 rectangles which had sum 2. Now if we remove those 2 rectangles, we'll also get 2 rectangles. Are you getting this particular point, that if we remove 2 rectangles of sum 2, we'll get exactly 2 rectangles of sum 3. So when you are removing 2 rectangles of sum 2, we'll get exactly 2 rectangles of sum 3. So again, we are going to add answer plus equals map of 2. So while calculating throughout, we are storing the prefix sum so that you can use in the future. And if we are already getting the particular thing in the map, we are adding that to our answer. I hope it is slightly clear now.
I understood the logic and how it's working, but one confusion that I still have is that supposedly, let's take the last example when we had prefix sum as 5, and we have to find all the rectangles whose sum is 2, so we can remove them and check their count, and that would be our answer. Although the solution is working, like there are 2 rectangles as per our count, and when we are removing them, we are getting those many rectangles whose sum is 3. But the rectangles which we initially count and the rectangles which we are actually removing are different, aren't they? Like in the last example itself, the 2 rectangles which had sum 2 and the actual ones in which, like the ones we are removing, are different. That's what I felt like in the end. Like if you can open that again, the slide. So like in the last case, we got 5 minus 3 equals to 2. So we are removing all of those rectangles whose sum is 2. But after removing that, we should again have a rectangle. So if you take top layer as the top as the first row and bottom as the second row, initially when we counted map of 2 equals to 2, we counted it in the first row itself. It was like the first 2 elements and then the first 3 elements, like if I'm not wrong.
Yeah.
But later on, when we are removing it from the rectangle of 8 elements, then the boxes which have sum 2 are actually different. Like because if we remove those, then it would no longer be a rectangle. Like that is what I thought.
Like
Like the first rectangle that we have sum 2 is like 0, 1, 1, right? That is one of the rectangles. So if we actually remove that from the rectangle of 8 digits, like 0, 1, 1, 0, 1, 1, 0, 1, if we actually remove 0, 1, 1, then it would actually not be a rectangle anymore. It's like we are removing 1, 0, 0, 1, like in the very end, that rectangle sum is 2. That is what we are removing to actually get a rectangle from the first 0, 1, 1, 1, that part. So that is something I got confused with. Like, how is this still working?
I hope I missed some edge cases.
Because we are maintaining a count of rectangles with sum 2, but when we are removing, we are actually not making sure that the rectangles which we are removing, it still remains a rectangle after we remove the rectangles. It's like it's a different set of rectangles that we are actually removing, and the count that we have stored, they are different set of rectangles, but it's still working. That's the part.
Okay, let me just check once. Okay, I might be missing some cases. Let me just know more about it, and I'll explain you. Okay, I'm missing something. Okay, so I'll just re-explain you once I get to know. I'll give it in the group. Okay.
Okay, Didi.
Okay. Any other doubt?
Didi, I could just switch on my video and show you what I am facing difficulty.
Yeah.
Yes, Didi. Suppose this is the case 1 1 0 0 and 0 1 1 1. Then if we are taking this triangle, so the prefix sum is 4, and suppose k value is 2, then we need to find like map is storing already this triangle 2, for the value 2 map is already storing this triangle and this triangle also and this triangle also. So this three triangles means for the value 2 it map would be storing 3. So for this triangle, we are having the prefix sum is 4. So we need to find 4 minus 2 equal to 2. That means from the map we need from the map we are getting the value as 3. So how we can remove these three rectangles? This won't give us the rectangle actually. This big rectangle, if we remove this 2 or this 2.
Okay, first of all, that part here, the extra thing that you're taking, because you're taking prefix sum up to like um 3 columns, right? So you are not supposed to take after 3 column. Anything we are not storing after, we are not taking anything after that 3 column. So we can
Okay.
remove one of the rectangles, that is 1 0, that is vertically okay, wait, we have stored another wait. Okay, so yeah, so one thing I missed, okay, I got both of your confusions. One thing I missed, that is top and the bottoms are fixed. Okay, so we are already, while iterating anything, we will always take any rectangle with top and bottom fixed. So you're not taking any rectangle with which is out of that. So we have to find any rectangle with the region where top and the bottom are fixed, but the uh, column is changing, right? So let me check in yours. What did you say? K is
K value is 2. So for this
so
rectangle,
one
the
of the
prefix.
rectangle I can see is in the top rectangle, horizontal rectangle
Yes,
that you can
yes,
remove.
this is correct. But how could we remove this rectangle?
Yeah, that is like the same doubt I had.
Yeah, the same thing. Okay. Okay, I'll get you know about this. I need to like see if I'm missing anything. Okay,
Okay,
I'll
Didi.
explain you when you.
Yeah, okay, Didi.
Baki, you got na like the overall concept how it's looking.
Yes, yes.
Anyone, any doubt? Anyone else? So you may leave the meet if you don't have any doubt. I'll
Thank you.
explain the rest of the question. I'll give the solution the clue.
Okay.
Okay, Didi.
Good night.